aluminium extrusions, which bolt together easily and have a degree of adjustability for aligning everything later. However, when I hit the frame with a hammer, it rings like a bell. So in the off chance it gets hit with a hammer again, I decided to disassemble the frame and fill it with sand and epoxy resin, often referred to as epoxy granite, which will hopefully dampen some vibrations. Whether this will affect the cutting quality is something I'll never know, but it definitely made everything a lot heavier.
It's definitely a lot heavier.
And this frame creates the mounting points which each 3 axes will travel along, and it's important that each axis will only move in its constrained direction, which is the job of these large linear rails. And in order to drive each axis, these large ball screws are used to transfer the rotational motion of an electric motor into linear motion. Though the actual motor of choice is a NEMA 34 stepper motor, which has far more control compared to a handheld drill, and each axis will have its own motor to move the cutting bit in all 3 dimensions. The 4th motor on this machine is the spindle, which is a very different type of motor, as it's designed to spin sharp cutting bits up to 24,000 RPM, with a power output of 2.2 kilowatts. And the wires for these motors can neatly pass through a cable drag chain that runs along the back of the gantry. Speaking of the gantry, this design of CNC machine is known as a fixed gantry design, which means it needs a work plate that moves back and forth along the y-axis. This is very similar to some 3D printers like the Prusa Mark IV, though my choice of design wasn't directly inspired by this. Many large CNC routers have a moving gantry design, which is great for cutting large sheets of material, but the design can lack rigidity due to the gantry having to move. Whereas a more precise milling machine, often used for metals, will have a much smaller cutting volume that moves in both X and Y, whilst a spindle is attached to a rigid pillar that moves just up and down. So my machine is halfway between the two, where the X-axis runs along a large rigid gantry that is fixed at the base of the frame, and also carries the Z-axis, allowing the build platform to be relatively large as it's able to pass underneath the gantry. This should hopefully be capable of cutting small precise parts for my projects, whilst also being able to cut sheets up to 500mm in both X and Y. But to control all these axes, we need a control board, which I've chosen to go with the Duet 3 6HC board, as it was recommended by a fellow YouTuber and CNC builder, Ivan Miranda. This board has some cool features, like high current motor drivers, allowing the motors to connect directly to these pins, and an Ethernet port for connecting to the internet, so it can be controlled by any device with an internet browser.
Perfect.
And once all the electronics were set up, I built a frame around the machine using some more extrusions, which will hold some thin sheets of aluminium to create an enclosure, as I don't want my workshop to get covered in metal chips. And with the addition of some LED lights, the machine is starting to look rather professional. I then added a clear polycarbonate door to the front, and a side bracket for a cheap touchscreen monitor that will be used to operate the machine. And finally wired up the spindle, which if you ever build a CNC machine, don't leave a loose collet nut on the spindle, especially if it spins the wrong way. The complete build of this machine is documented in far more detail over on my second channel, where I also go through the initial test cuts, which included turning the huge aluminium build platform